Today we're talking about lesson 612, conditions for triangle congruence. So we're talking about, are there any shortcuts? We're trying to discover what the shortcuts are so that we don't have to use such a long process in the future of proving that two triangles are congruent. Okay, here's a reminder that our process right now is that we have to do two different things. Number one, we have to show that the triangles are similar, either using angle, angle, side, or side similarity. And in addition to that, the ratio of corresponding sides must also be equal to 1. So in order to try to shorten that up and make our lives a little bit easier, we want to learn what the shortcuts are to proving triangles congruent. So today we're going to work on discovering which shortcuts are going to work. So what I have here is a combination of questions 6-12 and 6-11 from your book. And I did not go in order on purpose. I try to do the easier ones first and work our way up to things that are a little bit more complicated. So first of all, when I look at these two triangles, are the triangles similar? And the answer is yes. I know 3 sides of this triangle and 3 sides of that triangle. And if I were to match up the corresponding sides, A over A, B over B, C over C, even though we don't know what those are, they're all equal, okay? They're all equal to 1, which means they're equal to each other. So yes, these two triangles are similar by side similarity. Then we just showed that the ratio of corresponding sides is 1, rocks is 1, which means yes, these two triangles are congruent. So side is one of our shortcuts that can prove that two triangles are congruent. Next set of triangles. Are these two triangles similar? Okay, let's see the information that we're given here. Now remember, angle means 2 angles in one triangle and 2 angles in another. I don't have 2 angles that I know in that triangle. Okay, so there's no way that they're similar by angle. Okay, SSS means 3 sides on just one triangle, really on both triangles, but on just one triangle, not added together. And when I look here, I have 2 sides marked, but I don't have a third side. So there's no way it can be SSS. Okay, we're going to check to see if it's SAS or not. So I have 2 sides that are marked the same in each triangle. Okay, 2 sets of sides, 2 pairs of matching sides. Excuse me. And then I do have 1 set of angles. And if you'll notice, those angles are actually connecting the 2 sides that I know something about. This angle, this orange angle in both triangles are joining the green and purple sides. That means it's an included angle, and it's literally in between the 2 sides. So this is true, okay? And then we could either use the green or the purple to say, yes, the rocks is 1. Ratio of corresponding sides is in fact 1. It doesn't matter what the side length is. They're marked exactly the same in the 2 pictures. That means that the rocks is 1, okay? So the answer is yes. Side, angle, side is enough information to prove that 2 triangles are congruent. On the next slide, there are 3 different examples all on the same page, okay? And if you notice, every single set of triangles, so the first set, the second set, and the third set, all have 2 angles in each triangle that match 2 angles in its partner triangle, okay? 2 angles match 2 angles. I'd have to rotate and flip, but those are 2 angles that are marked the same. 2 markings, 1 marking. Here, they're all 3 are, but it only takes 2. So the answer is yes, all 3 of these are similar. All 3 sets of triangles are similar by angle, similarity. So we're off to a good start. Now, is the ratio of corresponding sides equal to 1? Well, let's look at it one at a time. In this one, I have no information whatsoever about any sides, none, okay? So we don't know what the ratio of corresponding sides is, meaning we cannot assume that these 2 triangles are congruent. Think about our dilations. If I have 3 angles that are exactly the same in 2 triangles, I could dilate, make one bigger, make one smaller, and they would not be congruent. They would be similar, but not necessarily congruent. okay? So AAA is not a congruence shortcut. Let's look at the second one, okay? Again, it is important that you see and understand, okay, this, I'm gonna make purple with an angle with one mark, an angle that has one mark. Those are definitely the same. This angle with 2 marks, this angle with 2 marks. So those two right there prove angle-angle similarity. Now, I have one more piece of information, and it's this side length, okay? I know that they're corresponding side lengths because they're touching purple and nothing, okay? So they're the same in each one, okay? Because it's purple and nothing, they're corresponding, they're the same. So are the rocks equal to 1? In this case, yes, rocks equals 1. So these are congruent. Angle side is a congruence shortcut. Last one on this page, let's take a look at this one again. I see 2 angles in each triangle that are marked congruent. Again, that information right there proves that the 2 triangles are similar. Are the ratio of corresponding sides equal to 1? Well, let's see. The only side length I know here is M, and it connects purple and green. M, purple and green. So those are corresponding sides because they connect the same colors. If I check my ratio, M divided by M is definitely 1. So rocks equals 1. So angle side angle is a congruence shortcut that helps prove 2 triangles congruent. Okay, next. This one. We start with an angle and an angle that are the same. Okay, I only know one angle from each, so there's no way angle-angle similarity can work. Also, I don't know 3 side lengths. There's no way SSS can work. Okay, I have no way to find that third side. I know 2 sides and I know an angle. However, this angle is literally sandwiched between the 2 sides. Here's Q, here's Q. Here's R, and here's R. And notice that although those angles are corresponding, okay, the angle connects the purple with the blank, that's true, but it's not connecting the 2 things we know about. So it is not SAS. It's actually ASS, or angle side side, spelled forwards or backwards, not okay to be a reason for proving congruence. These are not even known to be similar, okay? They're not necessarily similar. We don't even have to look at the rocks. We shouldn't look at the rocks because both of these 2 things have to be true in order for the triangles to be congruent, okay? Not similar, therefore not congruent. Gotta be similar in order to be congruent. All right, last one. This is kind of a tricky one. This one is showing hypotenuse, leg. If there's going to be a hypotenuse, it must be a right triangle. So we do know something about an angle, okay? And we do know something about 2 sides. The legs are the same, 1 leg in each triangle is the same, and the hypotenuse is the same, okay? Again, it's only 1 angle in each triangle. It is not angle-angle. I can't figure out these angles without more information. It is also not side angle side because this angle does not connect the 2 sides that I know. And you're probably thinking, well, there's no way it's side either because we don't know the third side. And you'd be mostly right, okay? If you're looking at this compared to our last example, you're probably thinking it's ASS or SSA, and you're right, but this one's a special case of ASS. It's special because of the right angle, okay? If I don't know this side length because of the right angle, I can say A squared plus L squared is equal to H squared. And if I want to find what A is, I can subtract L squared. Again, we would know numbers for those 2, so you could plug numbers in if you wanted to, okay? And then you take the square root, and although that looks weird, that is the process of how we would find what A is equal to, just using Pythagorean theorem, okay? Well, what about B? Okay, I would do the same thing. B squared plus L squared is equal to H squared. And I would subtract L squared, and I would take the square root. And again, that looks kind of weird and messy, But that's the process we would use for Pythagorean theorem to find the missing side. If you know two sides of a right triangle, you can find the third side using Pythagorean theorem. And if these two sides are equal to those two sides, these have to be the same. Okay, so really, through side similarity, we know the two triangles are similar. And because it's a special case, and L, the ratio L over L equals 1, we know that rhox is equal to 1, and therefore hypotenuse leg congruence is a shortcut. So to sum it all up, this is the most probably important one you write down and make sure you wrap your head around. If I know this information at the top, okay, if there's a check mark, it means that the triangles must be congruent. If I look at two triangles and all three side lengths of both triangles match up to equal each other, then the triangles must be congruent. The two that do not work, AAA and ASS.